And it goes a little something like.
Pleasant day, everyone. So, by the way, my name is Nasruddin S. Manyal, taking a Bachelor of Secondary Education, major in General Science. So, at this point, we're going to simplify and explain briefly using conceptual diagram the host defenses. So, what is host defenses? Host defenses are composed of two complementary frequently interacting systems. First, we have the innate or non-specific defenses, which protect against microorganisms in general. And second, the adaptive specific immunity, which protects against a particular microorganisms. The immune system has three lines of defense against foreign pathogens. First, we have the physical and chemical barriers, or belong to innate immunity. The non-specific resistance, and also belong to innate immunity, and the specific resistance belong to acquired immunity. The physical and chemical barriers form the first line of defense when the body is invaded. Physical barriers, for example, the skin has thick layer of the dead cells in the epidermis, which provides a physical barriers. Periodic shedding of the epidermis remove microbes. The mucous membranes produce mucus that trap microbes. The hair within the nose filters air containing microbes, thus pollutants. The cilia lines, which upper respiratory tract traps and propels inhaled debris to throat. The urine flushes microbes out of the urethra. Defecation and vomiting expel microorganisms. And the chemical barriers, for example, the lysozyme, an enzyme produced in tears, perspiration, and saliva, can break down cell walls and thus act as antibiotic kills bacteria. Next is the gastric juice. The stomach destroys bacteria and most toxins because of the gastric juice is highly acidic. The saliva, which dilutes the number of microorganisms and washes the teeth and mouth. The acidity on skin inhibits bacterial growth. The sebum, or the unsaturated fatty acids, provides a protective film on the skin and inhibits growth. The hyaluronic acid, which gelatinous substance that slows the spread of noxious agents, belong to the second line of defense, is the non-specific resistance that destroys invaders in generalized way without targeting specific individuals. For example, the phagocytic cells, which ingest and destroy all microbes that pass into body tissues. For example, the macrophages, which cells derived from monocytes or a type of white blood cells. The macrophages leave the bloodstream and enters body tissues to patrol pathogens. Next is inflammation, which localized tissue response that occurs when your tissues are damaged and in response to other stimuli. Inflammation brings more white blood cells to the site where the microbes have invaded. The inflammatory response produces swelling, redness, heat, pain, and etc. And last is the fever, which inhibits bacterial growth and increases the rate of tissue repair during an infection. The third line of defense is specific resistance. And the third line of defense is the specific resistance. And the third line of defense is the specific resistance under the acquired immunity. This system relies on antigen, which are specific substances found in foreign microbes. Most of antigens are proteins that serve as the stimulus to produce an immune responses. So here the steps in an immune response. First, when an antigen is detected by macrophage, as described above under phagocytosis, this causes the T cells to become activated. The activation of T cells by specific antigen is called the cell-mediated immunity. The body contains millions of different T cells, each able to respond to one specific antigen. Next is the T cells secrete interleukin-2. Interleukin-2 causes the proliferation of certain cytotoxic T cells and B cells. From here, the immunity response follows two paths. One path uses cytotoxic T cells and the other uses B cells. So the cytotoxic T cells pathway, first the cytotoxic T cells are capable of recognizing antigens on the surface of infected body cells. The cytotoxic T cells bind the infected cells and secrete cytotoxins that induce apoptosis, cell suicide in the infected cell, and perforations that cause perforations in the effective cells. And last is the both of these mechanisms destroys the pathogen in the infected body cells. While the T cell pathway, first the T cells can either directly destroy the microbes or use chemical secretion to destroy them. At the same time, T cells stimulate B cells to divide, forming plasma cells that are able to produce antibodies and memory B cells. If the same antigen enters the body later, the memory B cells divide to make more plasma cells and memory cells that can protect against future attacks by the same antigen. And when T cells activate or stimulate the B cells to divide into plasma cells, this is called antibody-mediated immunity. So that's all for this video. Thank you for watching.